On this F150 with the 2.7 EcoBoost, P0175 is a Bank 2 rich fuel control code. In plain terms, the PCM may be seeing a mixture on that bank that is richer than it wants, and the adaptive fuel strategy has reached its lean correction limit. The truck may run normally, or it can show rich running symptoms like roughness, fuel smell, poor fuel economy, or a check engine light. Keep the broad fault areas in mind: air measurement, exhaust or oxygen sensor feedback, EVAP purge, fuel pressure, injector behavior, fuel quality, crankcase fuel contamination, wiring, and connector condition can all be involved. Start with the basic system checks, then stay structured and do not clear the code or reset CAM yet. Record the ECT or ECT1 value from the captured conditions so you can reproduce the concern. If other codes are present outside this rich and lean fuel control group, check what they mean first before chasing P0175 by itself. With the ignition off, do the first visual pass before you get buried in data. Look for intake restrictions, damaged or loose intake tubing, throttle body restrictions or sludge, vacuum hose problems, EVAP hose issues, intake or gasket leaks, EGR leaks, PCV integrity, exhaust leaks, oxygen sensor wiring or contamination, cross-sensor wiring, and anything simple like the oil dipstick tube, or oil fill cap not seated correctly. If you find a vacuum leak, repair it and verify the repair before moving on. Be careful around a hot engine. If the concern is something else found during inspection, repair it as needed, clear the PCM codes, and run the self-test again. If nothing stands out, run the relative injector flow test. If that fails, the path supports installing the fuel injector in question, then resetting KAM, clearing codes, and repeating the self-test. If it passes, run the power balance test. If power balance fails, the path supports installing the affected fuel injector or direct fuel injector as applicable, then resetting KAM, clearing codes, and repeating the self-test. If both injector tests pass, keep moving. Next, check whether the EVAP purge valve is stuck open. Use the EVAP purge check if the scan tool has it. If that test is not available, install the fuel filler cap or remove the supplemental refueling adapter. Turn the ignition on, record FTPV, start the engine, command EVAP purge to 0%, and command the canister vent valve on at 100% duty cycle. The purge check passes if the tool says it passes, or if FTP PID voltage stays within 0.5 volts of the recorded value within 30 seconds after closing the purge valve. If it does not pass, the path supports installing a new EVAP canister purge valve, clearing PCM codes, and repeating the self-test. For P0175, when purge passes, go into fuel pressure testing. There is a shared vacuum leak branch in this fuel control routine, so use it when the inspection or branch result points you there. Start the engine and monitor CHT, ECT, ECT1, IAT, long FT1, short FT1, long FT2, and short FT2. Stabilize the engine at the captured ECT or ECT1 temperature if you have it. If not, maintain the engine coolant temperature between 82 degrees Celsius to 101 degrees Celsius, 180 degrees Fahrenheit to 215 degrees Fahrenheit, and the intake air temperature less than 46 degrees Celsius, 115 Fahrenheit. Add long FT plus short FT for each bank at idle. Then increase the engine speed to 3,500 RPM for 10 seconds. Record the trims again, and add long FT plus short FT for each bank at 3,500 RPM. The comparison is looking for the total fuel correction difference between idle and 3,500 RPM to be less than 15% of the total value at idle. If the MAP branch is reached, turn the ignition on, record MAP V with the engine off, start the engine, and confirm the MAP V PID value changes. To locate a vacuum leak, monitor short FT1 and short FT2, and restrict vacuum lines one at a time for 30 seconds. Do not clamp or pinch a hard plastic hose. Use a vacuum cap or equivalent. If the short-term trims drop by greater than 15% when a hose is restricted, that is the area to repair. After the repair, bring the engine back to the same temperature needed to recreate the concern. Compare the before and after short FT values and look for a decrease greater than 15%. If the trim change is not there, the leak is still present, so go back and keep locating it. If the universal HO2S pump cell circuit branch is reached, diagnose only the suspect sensor. With ignition off, disconnect the universal HO2S connector and PCM connector. Then on this 2.7 EcoBoost, measure the specified C172 to C1232T and C171 to C1232T circuits. Resistance should be less than 5 ohms. For the P0175 path, relieve fuel pressure using the proper pressure relief process. Connect a mechanical fuel pressure gauge, pressurize the system, start the engine, let pressure stabilize, then use the scan tool to command the fuel pump to maximum pressure. The pass or fail call here depends on the correct vehicle-specific fuel pressure range. If you do not have that range available, pause and get the correct spec before deciding whether the pressure is in range. If fuel pressure is in range for this 2.7 EcoBoost path, check for a biased FRP sensor. With the fuel injection pump connector disconnected, start the engine, monitor FRP, command fuel mass DI to maximum, and look for FRP between 345 and 827 kPa, 50 to 120 psi. There is also an FRP to FLP comparison in this routine. With the pump connector disconnected, start the engine and monitor FRP and FLP. FRP should be within 138 kPa, 20 psi of the FLP value. If either FRP bias check fails, the path supports installing a new fuel rail pressure sensor, clearing PCM codes, and repeating the self-test. If it passes, reconnect the fuel injection pump connector and check pressure stability. Run the fuel pump to maximum fuel pressure. Command the pump off, let pressure stabilize, record it, and monitor for 10 seconds. Pressure should stay within 34 kPa, 5 psi of the recorded reading after 10 seconds. If it does not, inspect the fuel tank, lines, and filler pipe for an external fuel leak. If an external leak is present, repair as needed. Then continue with fuel system diagnosis, reset KAM, and repeat the self-test. If the fast leak down passes, continue monitoring for 1 minute. The slow leak down passes if pressure remains within 34 kPa, 5 psi of the recorded reading, MRFS or greater than 275 kPa, 40 psi, ERFS after 1 minute. If it fails, stop this fuel control path and diagnose the fuel system leak down direction directly instead of guessing. If the shared branch sends you into an electrical noise check, inspect CKP harness routing, alterations, shielding, interference from other systems, radio frequency interference, and excessive audible generator noise. If pressure stability is good, check fuel quality. Use a 200 milliliter beaker and a 25 milliliter graduated cylinder. Put 5 milliliters of clean water in the beaker. Drain 22 milliliters of fuel into an approved clean container. Pour 20 milliliters of that fuel into the graduated cylinder. Then add enough water to bring the total liquid volume to 24 milliliters. Stopper it, shake it, let it separate for approximately 3 minutes, and record the separation level where the ethanol and water layer meets the gasoline. If the mixture does not separate, the path supports replacing contaminated fuel, clearing PCM codes, and repeating the self-test. If it does separate, calculate ethanol percentage by taking the recorded separation level, subtracting the water added, and multiplying the result by 5. If ethanol is present on a flex fuel vehicle, compare FFINF to the calculated ethanol percentage. It should be within 20% of the calculated value. If it is not, reset KAM, start the engine, watch FFLRND, and drive approximately 11.3 kilometers 7 miles or until FFLRND indicates yes. Then, cycle the ignition and compare FFINF again. If the updated value is within 20% of the calculated ethanol percentage, return the vehicle and advise correct flex fuel fueling practices. If it is not, move into the fuel system direction indicated by the test, and do not guess. On non-flex fuel, if the calculated ethanol percentage is less than 25%, continue the P0175 path. If it is not less than 25%, repair is necessary, advise correct fuel type, reset KAM, and repeat the self-test. After fuel quality checks, inspect the oxygen sensor side. With ignition off, disconnect the universal HO2S connector and look for pinched, shorted, or corroded wiring and pins, oil or water contamination, crossed wires, and a contaminated or damaged sensor. Repair any concern found, clear codes, and repeat the self-test. If the inspection is clean, check MAF functionality. Start the engine, monitor RPM, MAFV, MAFHC, and MAF. Run the engine up to 1,500 RPM for 5 seconds. Return to idle and repeat once. At idle, the PID value should be within 30% of the normal value listed for the vehicle. If it is not, stop and diagnose the MAF direction directly. If MAF passes, connect the universal HO2S connector and check sensor activity in closed loop. Monitor fuel sys CL, RPM, EQRAT11, and EQRAT21. Then increase engine speed to 2000 RPM for 1 second and return to idle. The expected activity is for the equivalence ratio signal to cross 1, either from greater than 1 to less than 1, or from less than 1 to greater than 1. If it does, the concern may not be duplicated at that moment, so pause, recheck the earlier diagnostic path, and avoid guessing. For P0175, if the universal oxygen sensor activity check does not pass, check for fuel leakage into the crankcase. Start the engine at normal operating temperature. Monitor long FT1, SHRTFT1, long FT2, and SHRTF2 and record the values. Turn the ignition off. Disconnect the PCV line at the intake manifold and temporarily plug the intake manifold port. Restart the engine, idle at normal operating temperature, and compare the current trims to the recorded trims. If the trims shift and the rich condition is no longer present, the path supports installing a new fuel injection pump, clearing PCM codes, and repeating the self-test. If the rich condition is still there, move to the connector and universal HO2S operation check. If the running test sends you into the downstream HO2S code branch, run the engine at approximately 2000 RPM and maintain the engine speed for 3 minutes. Then check whether the specified downstream oxygen sensor codes are present. If they are, diagnose the suspect sensor indicated by the code. With ignition off, disconnect the PCM connector and the appropriate HO2S connector. Then check for shorts between circuits in the HO2S harness. The resistance check should be greater than 10K ohms. If that passes, check the HO2S circuits for opens. Those resistances should be less than 5 ohms. Then turn the ignition on and check the HO2S circuits for a short to voltage. If voltage is present where it should not be, repair the short, clear codes, and repeat the self-test. If no short to voltage is found, reconnect the PCM and HO2S connectors. Start the engine. Allow the engine to idle for 2 minutes and record the HO2S voltage PID. The voltage should be less than 1.5 volts. If that voltage check passes and the concern still cannot be duplicated, pause, recheck the earlier diagnostic path, and avoid guessing. If the flex fuel learning path cannot complete, check PCM connector condition. With ignition off, disconnect the PCM connectors, inspect for pushed-out pins and corrosion. Reconnect everything fully, and verify whether the concern is still present. If it is still present at that point, the path supports installing a new PCM. If it is gone, the system is operating correctly, and the concern may have been caused by a loose or corroded connector. If the P0175 path reaches the universal HO2S operation check, turn the ignition off, disconnect the PCM connectors and the universal HO2S11 and HO2S21 connectors. Inspect for pushed-out pins and corrosion, then reconnect everything and make sure the connectors seat correctly. Reset KAM and verify whether the concern is still present. If it is still present, the path supports installing a new universal HO2S, resetting KAM, and repeating the self-test. If it is gone, treat it as a connector-related concern that is now corrected. If the downstream HO2S operation branch is reached instead, disconnect the PCM connectors and the HO2S12 and HO2S22 connectors. Inspect for pushed-out pins and corrosion. Reconnect everything fully, reset KAM, and verify whether the concern is still present. If it is still present, the path supports installing a new HO2S, resetting KAM, and repeating the self-test. Keep verification separate from testing. After any repair, clear the PCM codes when the path calls for it, reset KAM when the path calls for it, run the self-test again, and confirm P0175 stays gone under the recreated operating conditions. P0175 is not just an oxygen sensor code. Work the rich Bank 2 fuel control path in order. Prove purge, pressure, fuel quality, air measurement, crankcase fuel, and connector integrity before you condemn anything. For more diagnostic training, visit stepdiagnostics.com.